everyone. This video is going to be about molecular effusion and diffusion. Okay, so you've probably heard these words before, like something, diffused, or you had to use a diffuser of some sort. So now we're going to talk about what these words actually are. So let's first start with effusion. Okay, so effusion is the escape of a gas molecule through a tiny hole into an evacuated space. Okay, so I want you to think about like if you were to have a helium balloon, and I know y'all have done this before, right? So you have a helium balloon, you make a little bit of a slip, and then you suck it into your mouth so you change your voice. And that's effusion, right? Because you're making a tiny pinhole into the balloon so it can escape into your mouth, right? So you can kind of see the image that I have here. So the first example is the helium that I'm talking about. As it moves into the evacuated chamber, you'll notice that there's more molecules of helium, right, than the one on the right, which is ethylene oxide. If I was to compare their two masses, helium only weighs 2 grams per mole, which then means, ethylene oxide weighs way more, okay? And what we see happening is that the helium effuses quicker, where the ethylene oxide effuses slower, right? And if we think about why that's happening in comparison to the two molecules, it's because of their molar mass. So substances that have smaller molar masses will effuse through a pinhole much faster than one that has a heavier molar mass. Okay, so let's look at an example then with knowing that. So of the following gases, blank will have the greatest rate of effusion at a given temperature. So let's kind of think about what greatest rate of effusion means. If I look back at the previous slide, helium was effusing more, right? Because there was more substances here than this one. So for this exact problem, we're going to need to know the greater the molar mass, the slower the rate of effusion. So in order to answer this question, we need to know who has the smallest molar mass, because we want that substance, it's going to effuse much quicker. Okay, so here I've already calculated the molar masses for each of these substances. HBr 80, argon 39, CH4 16, NH3 17, HCl 36. So with that being said, who is going to effuse at a really fast rate in comparison to everybody else? And the answer to that is CH4, okay? CH4 is going to effuse quicker because it has the lowest molar mass. And then NH3 is a close second behind it because it's only off by 1 gram. Okay, so that's effusion. So now let's talk about diffusion. Okay, so let me move myself so you can actually see the images that I've put here. Okay, so diffusion is kind of like effusion. However, diffusion is the spread of one substance throughout a space or a second substance, okay? So I want you to think about this in terms of, and don't make fun of me, this is the same exact example that my professor in college gave me. Think about when you or somebody that is in your class farts, right? Why can everybody smell that fart? Well, it's because the fart left that person and is now diffusing into the oxygen. So it's combining with the second substance, which is the stuff that's in the air. And then it starts to spread throughout the room, right? So if somebody lets off a pretty good fart, that thing can diffuse all throughout the classroom and then everybody can smell it. That's one example. Another example would be perfume, right? So it's important to note that if people are sensitive to perfumes in classes, you need to make sure that you're not spraying, because ultimately you could put that person at risk because that perfume will diffuse all throughout the room. Okay, so here's an example. So let's go back to our fart, right? So this is before you fart, right? Because so this is your fart, and these are the air molecules. And then what happens is they are diffusing together, right? So you have your mixture of your fart particles and your air particles, right? Now, if molecules are escaping from a container, it's the same sort of process, okay? couple of other things with diffusion. Diffusion will be just like effusion, will be higher for lower molar mass molecules. And the reason why farts spread better than spray is because farts have a lower molar mass. Okay, so let's look at an example problem. So I'm going to move myself back up here. And let's kind of think through it. So it says a thin glass tube 1 meter long is filled with argon gas at 1 atmosphere. And the ends are stopped with cotton plugs. Okay. So like, what are cotton balls or whatever. HCl gas is introduced on one side of the tube. So we're putting gas over here and NH3 over here at the other end. When the two gases diffuse through the cotton plugs down the tube and meet, a white ring will appear due to the formation of ammonium chloride solid. Okay. So the question is, at what location, A, B, or C, do you expect the ring to form? So the question that we should be asking ourselves is, who diffuses faster and who diffuses slower? Or do they diffuse at the same rate? So first of all, the location depends on temperature. That has nothing to do with it, okay? So we're going to ask ourselves the question is, first of all, what are their molar masses, right? So we have to think about molar masses. If their molar masses are equal, where will they meet? They'll meet at B, right? Because they will diffuse at the same rate, okay? If HCl has a higher molar mass, what's going to happen? NH3 is going to beat it. It's going to be going faster. HCl is still moving, but NH3 is going to be moving faster because it's smaller, right? Or it can be C, the opposite, right? So NH3 is going to be moving slower, where HCl is moving faster. So that's where it'll meet. So with that being said, we need to know the molar mass. So HCl has a molar mass of 36.46 grams per mole. NH3 has a molar mass of 17.04 grams per mole, which means HCl is the larger molecule. So what's going to happen is it's going to be diffusing at a slower rate than NH3 is. So with that being said, where do we think the solid will form? Location A is correct, okay? Because like I said, NH3 is a smaller molar mass, so it's moving quicker. HCl is moving, but not at the same speed as NH3. So therefore, the salt will form closer to HCl. Okay, so let's kind of compare and contrast here, right? Okay, so they kind of do the same thing, but they mean different things, okay? So effusion versus diffusion. So first of all, diffusion is when you remove an obstacle for the gas to expel, right? So if we think about the spray, the spray that makes you smell good, like perfumes, what you're ultimately doing is your partition is when you go to get to the spray. So, and as soon as it's let out into the air, that substance is going to diffuse. Where with effusion, we're talking about a specific small space that a substance is flowing through. So think about like a straw. If you blow in a straw, right, your only certain amount of oxygen molecules are going to go through. Or like I said before, if you poke a hole in a balloon, that is also considered a pinhole. All right, that's it. Thanks, y'all.